mentor, Mrs. Newbeck, was instrumental in providing us with her expertise in order to make our mission a success. She provided guidance and knowledge that truly propelled our mission to new heights. Her invaluable contribution was key to the successful implementation of our mission throughout the week. We began planning our 3D tool, which was engineered to be effective in confined spaces, specifically within the hypothetical scenario of an astronaut extravehicular repair. In this manner, our team collaborated and designed our tool.
Next on our schedule was a trip to Space Center Houston, where our first stop was a tour of the SAIL building. Equipped with an astonishing array of electrical arrangements and insulated wires and circuitry, this building was astoundingly complex and provided vast insight into everyday operations at NASA. Shortly afterward, we left the Avionics Integration Lab and continued with our next mission.
Our next assignment was to create our very own rockets to be used in a launch the following day. Bearing specifications ranging from wing design to overall rocket length, each student designed their rocket to minimize drag and resistance in order to achieve the highest average team altitude during the subsequent launch.
Our rover design was another integral part of our week's mission, engineering it to perfection in order to maximize its effectiveness, maneuverability, and ensure success in the rover competition. Our design consisted of a bulldozer approach to effectively push the crashed specimens on the simulated Mars surface to the safe extraction zone to successfully partake in the competition.
On Wednesday, our mission led us to the Integrated Power, Avionics, and Software Division, or IPADS, where the team met electrical, computer, and mechanical engineers in charge of creating the habitat environment within the Orion space shuttle.
The culmination of our project consisted of the final PDR presentation, wherein our team elaborated on the specific mechanics and logistical issues that were vital in order to get to Mars. Our team researched and discovered information pertaining to potential risks, interplanetary transit, and the final entry, descent, and landing phases at Mars. The building of the model was probably the most fun and memorable experience I've had this week, collaborating with others to succeed together.
Lastly, the crew exercise presentation on Thursday was very important and highly informative, as an often overlooked portion of interplanetary travel was addressed with the due diligence it deserved. Ms. Moore displayed the up-and-coming designs of NASA to ensure astronauts' physical well-being.
This brings us to an end here in Haas Week 3 at Johnson Space Center. Throughout the entire week, we were immersed in an academic professional environment that truly embodied all that NASA stands for. After a whole week of interactions with engineers, Alpha Centauri has learned innumerable lessons and is ready to tackle the world's problems.